Huh? Tomorrow, right? Is it the strength from first class? ಇಷ್ಟೇ ಜನ ಬಂದಿರೋದಾ ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಂತ? ಕೃಷ್ಣ ಎಲ್ಲೋ? ಕೃಷ್ಣ ಲ್ಯಾಬ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿ. Right. So what we have discussed in the last class? Did we wrote any program? ಎಲ್ಲಿಗಿದ್ವು? ಈ ಪ್ರೋಗ್ರಾಮ್ ಬರ್ದಿದ್ವಾ ಏನಿದು? Square one, which is a half frequency of this. Have you understood this program? Aspect. If there is no interrupt, you should keep checking whether the event will tell you that like yes, I have occurred. Please do something. Frequency of the wave that is given as input to port number 1.3 or port number 3.2. Correct, right? So where is that? 1.3? 3.2. Yeah. It is like this. Yeah. See, this is given as an input to port number 3.2. You have to generate another square wave at pin number 1.3, which has a half of the frequency of this signal. How do you do it? Do it for every negative edge. Every negative edge, one trigger. Every negative edge, give one trigger. Trigger, what it does? CPL equal to CPL P1.3. Make this pin is actually INT0. INT0 pin. Enable that pin. Whenever there is a negative edge on this pin, then you run some program. Whenever there is a negative edge on this pin, if this pin interrupt is enabled, your PC will jump to some value. What is the value? Zero vector table. Whenever there is a negative edge occurred here, like it will go to 0, 3 and execute this program and then return back. This code can be written at 0, 3 only and only if it is less than 8 bytes. Now it is of 1 plus 2, 3 bytes. That is why I have written here directly. If it is slightly bigger code, it is suggested to write ljump here, ljump to somewhere VMS, then like in VMS you write a. Are you getting what I am saying? We have written this program class. Have you understood that? Or should we have to, we will write one similar kind of program today also, so that we will practice on the timer interrupts. Is there any doubt in this program? We have finished this program in the last class, or like we have left in the middle. We have finished, right? So is it understood? Right. Today what we do is, we will generate a square wave of 5 kilohertz and 25 kilohertz on two different pins, 1.3, 1.4. How do you do this program? You have to generate a square wave, two square waves, one from pin number 1.3, another from pin number 1.4. The square wave at pin number B of 5 kilohertz, the square wave at pin, to generate these two, and this should be simultaneous. How do we do this? Okay, one more thing. The oscillator frequency F clock is, if they have not given, you should assume as 11.0592 megahertz. If they have given, you should do the calculation with respect to that. Right, tell me what is the first step. How do I do it? How do you generate a square wave? Complement a pin, call a delay. The delay must be period of a one pulse. Period of one pulse. You know how to calculate a period of a pulse, right? Now you have to generate without interrupt. Can anybody tell me that? Don't think, worry about interrupt. How do you do this two square wave generation without interrupt? Okay, so these are the multiples, it is easy to calculate. So if we change this multiples as 23, I didn't get you. Thing is like call a delay of 1 millisecond or less than that. Call this for 5 times, call this for. When you are calling that in sequence, don't you think the another signal is getting affected? You're understanding what I'm saying? Shall I write it? You understood what I'm saying? No? Right. Define some X amount of delay. X delay. Let us say in this case, it is 1 millisecond. Will at 5 kilohertz, this is what is the thing? 5 kilohertz is 0.2, right? 0.2 milliseconds. 0.2 milliseconds. For 25, what will be the answer? 0.4 milliseconds. 0.04 milliseconds. That means one pulse is of 0. And here the one pulse is of 0.1 millisecond. Correct, right? What is the easiest way to explain this now? Like, if I make it as 10 kilohertz, this will be 0.1, this will be 0.5, right? Let us go for the easiest one. We'll just see, without interrupt, can we do this? 10 kilohertz, easiest one. Once it is 10 kilohertz, what will be the, here, 0.1 millisecond. Half of this is 0.5 millisecond. Okay. So my delay unit X is 0.05 milliseconds now. If I am generating this wave at this, I will call it twice. If I am generating this, I will call it once. If I write a program now, it will be in sequence. What should I do? CPL pin 1.3 delay. Only once I have to do. This will generate, each of this will generate 0.05 millisecond. That is what we have assumed. So now it is in together, it is 0.1 millisecond. Then what should I do? If I use this CPL P1.4 and delay here, this will generate 0.05 millisecond. In total, for this one, again I will do S jump here, S jump to here one. When I come back here, it is having 3 delays. .4 here, in the middle here. Yeah, this delay will really remove it. Just CPL P1.4, this is a delay. CPL Again here. Are you sure? Okay, we'll try what is Hasib is saying. Today he is speaking, we'll encourage. Right, what happens with this now? Guys, listen. We have not written a delay, but we are assumed that delay will be this thing. You write using DJ and Z or timers, it is lefty. Once this delay is occurred, this causes 0 second, and then like we'll go and change this status of 1.4. If it is 1 first, then it will become 0. Wait for a delay of 0.5 second, and then like change the status. Then S jump back here, change this, then I'll call a delay again. So this delay will be this part. Again change the P1.3, it will run. It is running proper for P1.4. What about the P1.3? It is going good for that also. Yeah, we'll come back to that. Then like this delay, go back. Yeah, it works for both. Of course, there are some instructions added in between, but they are very minimal. Considering to the 0.1 millisecond, this is in microsecond. So it can be a negligible small amount. You can write at the end. Delay is added with these two instructions, which is considerably very small. Okay, this is correct. It is working fine now. It is working fine if it is 10 kilohertz. If I make it as 13 or like some other number, which is not the multiple of these two frequencies, right? Then it is going to be really difficult to write kind like this program and generate a 2 square wave. Is there any way in which we can do both of this, even if it is an not matching thing? Is there any? 25 is again this thing. We'll take 13 only. kilohertz. For 13 kilohertz, what is the time duration for one pulse? 1 by 13. How much? Huh? 0.07632 na? Divided by 2 I have to take one pulse duration. 38. Correct? Right. So this is a minimum required time delay for 13 kilohertz. 0.1 millisecond is for this one now. Right? Quickly, can you tell me the timer value for both of this? If I imagine to generate this, I use timer 0. To generate this, if I use timer 1. Can you tell me the timer value quickly? 22 megahertz. First thing, what do you need to do? 22 megahertz divided by 12. Then get the frequency of the machine cycle. What is the frequency of machine cycle? 22 megahertz. 22 divided by 12. Not 1.8. 1.8. 1.8. Correct. Then time for this. Time for one machine cycle. Huh? 0.5456, something like that. So we'll assume 55. We'll assume 55 microseconds. So this is the time taken for one machine. What will be? How do I do this? 0.55 microsecond for one machine cycle. 0.1 millisecond is for how many machine cycles? Quickly, can you tell me the number? 0.1 millisecond divided by Balaji chop is idava. Huh? 0.1 millisecond divided by 0.55 microsecond. 180? 181. So here it is 182. 182 is in decimal, hexadecimal value. Huh? So this is my value for, yeah, listen, this is my value for timer 0. 5 kilohertz, right? Yeah, timer 0 value. So what I do now is, as it is only 8-bit value, I can easily do it with auto reload mode. If I put this in the, to continuously generate any wave, like auto reload mode is a suggested mode. If I put this in the TH0, whenever your TH, so it goes from B6 to FF, B6 to FF always. Generate that, oh sorry, B6 FF minus this thing, or minus B6. Minus B6 or FF minus B6. What is the value? What is the value? Yeno value helappa. 49? 49H. Yeah. So now from here it is FF minus 1. Not forget plus 1, because after overflowing to 0, 0, your flag will set. 4A. So this, TH0 value is that one. TH0 should hold the 4A. Now from 4A it will go to FF, overflow, come back to 4A, it will keep rotating from 4A to FF. That is the time delay that it generates, right? This is the time delay, that is 182 cycles delay that it will generate. Similarly for timer 1, quickly. I am not going to write anything here. You should tell me what is the value of timer 1, TH0, directly. Same procedure. In here it is 0.038. For 0.038 divided by 0.55 microseconds. Bega. Huh? 43 for what? Final answer. 43 Hz. If I put it to 43 Hz, what is the number of machine cycles you got? ಜಾಸ್ತಿ ಆಯ್ತಲ್ಲ, ಹೆಂಗಿದು? How come? This is 43, 40. FF minus 43 has to be done. Once again, he has done something mistake. Tell me what is the number of machine cycles first. 69 machine cycles. Sure? Might be around 69 machine cycles. Right, next. 69 in decimal, hexadecimal, FF minus that number plus 1. B. For TH0 directly. That is, what is the value of 69 machine cycle in hexadecimal? 45. 45 in hexadecimal, and then you should do FF minus 45 plus 1. How much? B. TH1 value is B. This is a calculation that you have to do first. And keep in mind, this will not generate you an exact delay. Why? Because first assumption is here. You have assumed, you have truncated a value to some value. Second assumption, when you divide this, you will have some truncation. In here also you will have some, approximation. You will not have an exact value. Around that value, this will be there. Any time to write 3 lines at the end of the program. Write every program and write exactly below there. There has been assumption at this point, and this point. Hence, and this is only for, you have to remember this also. This calculation is one which generates a time delay with respect to timer. There are some other instructions in between. For example, return. 2 machine cycles we have not calculated. Those are all you should write at the end. Okay, we'll try that now. Is it clear now? So what I had, that 2 square wave. What is the first step? What is the first step? What is the first step? This syntax that I am writing, it is true for all the interrupt programs. Ljump. Ljump main. Why should I do this? This is a vector interrupt address. IVT number 0000B. Timer 1 001B. So from here 00 you start in the ROM location. At ROM location 00B you should write one code which is specific. You cannot write whole program here which will overlap with this address. That is why we will take Ljump somewhere and write the other part. For example, we will write at org 30H. This is my main. This is my main program. What should I have to do in the main program? I have to do in the main program. Tmod. Move Tmod. What is the value? What is the value for Tmod? Both the timer 0 and timer 1 are in auto reload mode. Auto reload mode. That means both the modes are 2. So mode 2 for us. Clear? ಏನು ಡೌಟು ಅವನಿಗೆ ಏನು ಡೌಟು 1 millisecond 1 millisecond ಡಿಲೇ ಬರಬೇಕು 1 millisecond ಡಿಲೇ ನಮಗೆ 0.1 millisecond ಬೇಕಮ್ಮ No. We want a delay of 0.1 millisecond, not 1 millisecond. If you go for 0.1 millisecond delay, you cannot call it again because it has fractional other number. If it is a multiplication like we have taken 5 and 10, then it is easy. What you are saying is right. If it is non-multi, then it is very difficult. Like this, you now double this or triple this, it will never be 0.1 millisecond. You're understanding? If this delay is a multiplication of this, multiplication factor of this or multiplication result of this, then it is whatever you are saying is right. That is what we have discussed first. If this is 5 kilohertz, if it is 10, 15, 20, 25, then it is easy. If it is 13, then it is a problem. You rethink on the point. Right, guys, listen. Are you sure it is 22? Whatever you are saying, I am writing here, okay? Right, next what should I do? T at 0, okay. We will finish this timer thing and then we will go to IE. Move TH 0, TH 0, what is the value? Hash 4AH. Next move TH1, hash BH. Next. So timer is ready now. That's clear. Timers are ready. Next, what should I do? Interrupt. Now, what is the interrupt? The program. We interrupt this one. What should I do in the interrupt? Which register? IE register. What should I write to IE? For the clear understanding, we'll write it again. Enable all. Can you tell me this? Enable all reserved bit. Next. Huh? ET2, ES, ET1, EX1, ET0, EX0. Correct? Correct. Right. Both timer 0 and timer 1. The remaining is 0. This has 1. This has to be 1. As I told you, this is the main power supply. Once this is on, then like the power will go to all of this. Okay. So what is the value now? 85. 8A na? 8A. This is 8AH. That means I have enabled both the timer interrupt. I have enabled both of this. Next, what should I do? Next, what should I do? Start timer. Start timer now. Okay. What should I write for start timer? Set bit TR0. Set bit TR1. Timer started. Next, what should I do? Start in the main program. Very important. After setting all this, what should ALU have to do? ALU should simply wait and watch what is happening. It should do simple time waste, otherwise you have to give some job to ALU. Right? Then what has to be next? End here. Next, what I have to do? What has to be done? What has to be done when this is start now? When this timer 0 is started, it will start from 4A and go up to FF. Then it triggers an interrupt. When it triggers an interrupt, what should I have to do? What is there? 00B. ORG 00B. H. In here I should write some program. What is the program? CPL P1.3, right? Okay. Then, right, similarly, ORG 001B H CPL P1.4 RETI, return on interrupt. Any doubt in this? This is very, very important program, and this is the last program that we are doing in the timer interrupts. Next we will do the hardware interrupts, interrupt 0 and interrupt 1. The structure of the program for interrupts, it remains same. ORG 00H, LJump to main. In main you write all the setups only, and whenever there is an interrupt occurs, it goes to those particular memory locations. Interrupt which is mentioned in interrupt vector table. In that memory location ORG 00BH, you should write your interrupt program. This is a standard structure for all the interrupts. Parag, hello, you know. No, whenever then it loads the value. Auto reload mode. There is one very important point in this which I have not told. Let's see if anybody can guess it. From 00 to okay, then we have to write one instruction in which move TL0 equal to TH0. There that way should I forgot it. What is that like? What exactly happens in that? That is a case like you should include one instruction there, move TL0, TF0. TL0, then leave it. First time you should put it. Solve ಆಯ್ತಾ? ಏನು ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಇದೆ? 38 ಹೌದು. ಒನ್ ಮೈಕ್ರೋ ಸೆಕೆಂಡಿಗೆ ಡಿಲೇ ನೋಡಿಲ್ಲ ನಂದಲ್ಲಿ ಒಂದು ಮಷಿನ್ ಸೈಕಲ್ ಬರ್ಕೋ ಹೇಳ್ತೀನಿ ನಾನು ಕರೆಕ್ಟ್. ಒನ್ ಮಷಿನ್ ಸೈಕಲ್ ವ್ಯಾಲ್ಯೂ ಬರೀ. ವಾಟ್ ಇಸ್ ದ ಒನ್ ಮಷಿನ್ ಸೈಕಲ್ ವ್ಯಾಲ್ಯೂ? 0.55. Right. Your subroutine contains FE now, timer value. FE, FF, then timering is over. They will be called so many times. This will be called 100 times for this. This will be called 30 times for this. And every 100 times you are including that extra machine cycle. ಅರ್ಥ ಆಯ್ತಾ ನಾ ಹೇಳಿದ್ದು ನಿನಗೆ? ನಿನ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿದೆ, ಅರ್ಥ ಆಯ್ತು ನನಗೆ. ದಿಸ್ ಇಸ್ ರೈಟ್, ಬಟ್ ದಿಸ್ ಈಸ್ ಆಫ್ ಮೋರ್ ಎರರ್ ಪ್ರೌನ್. ತುಂಬ ಎರರ್ಸ್ ಅಕ್ಯುಮುಲೇಟ್ ಆಗ್ತಾ ಬರುತ್ತೆ ಇಲ್ಲಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ರಿಟರ್ನ್ RETI is 2 machine cycle, we have not calculated it. ನಿನ್ನ ಕೇಸಲ್ಲಿ RETI is 2 machine cycle into 100 times. ಸೊ 2 ಮಾಡ್ಬೋದು. ಬಟ್ ಏನ ಪ್ರಾಬ್ಲಮ್, ಇನ್ನೊಂದೇನು ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ ಗೊತ್ತಾ? ALU keeps calling this interrupts very often. So ALU will be very busy. ALU ನ ಬಿಸಿ ಮಾಡ್ತಾ ಇದ್ದಾನೆ. ಯುವರ್ ಮೆಥಡ್ ಇಸ್ ರೈಟ್, ಬಟ್ ಇಟ್ ಈಸ್ ಮೋರ್ ಬರ್ಡನ್ ಥಿಂಗ್. ನೀನು ಎರರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದ್ರಲ್ಲಿ ನೀನು ಅದನ್ನ ಮೈನಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡ್ಬೋದು. ದಟ್ ಈಸ್ ಆಲ್ಸೋ. ನಿಂದೇನು ಡೌಟ್? ಗೊತ್ತಾಯ್ತಾ? ಕ್ಲಿಯರ್? ನೋ. So that you can put anywhere, but this address has to be standard. ORG B00B has to be there. You can write it after that, below that it is fine. Any doubt? Guys, is there any doubt? 50-50. Yes. This is what I was expecting. Now what I said, when the timer reaches from 48 to FF, TF flag will set, TF0 will set. On TF0 set, this program is called, right? This program is executed. Who will clear the TF0 flag? Two aspects. Has a special feature that it clears whichever the flag is set. It clears and comes back. This program is called because of some flag is set. Once it executes it, RETI will clear that flag. Even if you are written in normal mode. Even if you are written in the normal mode, RETI has this feature. After this program, please write that. 2 sentences about RETI. RETI and RET. You remember RET? RET for what? Normal subroutine, when there is a call, there is a return. Right? Now below we write that. We are comparing these two instructions now. Right? Both the instructions will do the same function of popping 2 bytes of address value, popping 2 bytes of address value from stack to PC. Is it clear? Is this statement is clear? Both the instruction RET and RETI will pop 2 bytes of address from the stack to PC. Which address is this? In whichever the process is executing, The next address, next executable instruction address is stored in the stack, and then like it went to the interrupt service routine. Once it finishes that, it has to fetch that, then execute it. In this case, it is only one, it does not matter. When there are 10 instructions like this, then it matters. You're understanding? Both of this will do same function. Next line. Next line. RETI will do some, RETI will perform an additional task of clearing interrupt in service flags. Interrupt in service flags. Interrupt in service flag means what? Whichever the flag has enabled the interrupt service routine. For what reason it comes here? Because TF0 flag related to this is set. Once it is returning, it will clear that flag. We call it as interrupt in service flag. Interrupt in service flag. Is it clear? Oh, we'll come to that. There is a priority stake which is exactly out of syllabus, but still we'll mention a point on that. Yeah, next line. Indicating, continue that sentence. Interrupt in service flag, indicating interrupt servicing is over and controller can accept new interrupt. And controller can accept the new interrupts. Therefore, in the above program, there is no need to clear. Therefore, in the above program, there is no need to clear. Therefore, in the above program, there is no need to clear the timer flag. Right? So, this part of the code, timer 0, that is what? ET0. This part of the code is for ET1. Whenever timer interrupt 1 happens, timer interrupt 0 happens, this is what executes. Right? Done. So what we do next, we'll go for hardware interrupts. Yeah, he had the same question. If two interrupts arises at the same time, it goes based on the priority. By default, in the order that we have given. Reset has the highest priority. After reset, what is the next instruction, next loop? In the interrupt vector table, 003, INT 0, that has the highest priority. Next. TF0, this has the highest priority. So TF0, TF1 occurs at a time. TF0 will be served first. Right? Next. It goes in that order. Now we want to change the priority of this register, IP. It is there in the SFR, but that is not there in your syllabus. That is the point. You want to write it? Please mention it, one line. If two interrupts occur at a time, then ISR is interrupt service routine. ISR related to the highest priority interrupt. Will execute first. Next. In such a case, you will not get a delay. You will not get an exact value. What you said, that also you got it. Like in such a case, if two interrupts occur at a time, you are generating a delay in here, then like it will not be exact. There will be an issue. That happens. Again, for that there is a solution. That thing, like they call it as atom code or something like that, where in which that part of the code which is very, very important in your whole program, you should disable all the interrupts, execute that and enable interrupts. So no interrupt will disturb that piece of the code. That is not there in syllabus, don't worry. You are just like... Huh? Didn't get you.
You have to get two square like one.
Yeah.
Without any disturbances, then you have to do multitasking.
No multitasking. We are not doing multitasking anywhere. This is multitasking is, there are two aspects. I'm not...
Like, if you want to get same square root, like at one, then you have to use multitasking, you can't get it in.
Right, listen to me then. Multitasking is impossible when you have a single core. Every core, ALU, has one ALU, it executes possible. You want to do multiple tasking, there has to be dual core. Point number one. Point number two is otherwise like you need single core with a OS which runs program 1 for certain duration, program 2 for certain duration. Then like it feels like multitasking. Internally it is actually sequential. Right. Shall I run this? Any doubt in this? Any other doubts? Oh, there is one more small thing that we have to explain this itself, but I forgot. Yeah, right guys. Next one, hardware interrupts. Whatever we have discussed till now is the timer interrupts. There are two timer interrupts that we have discussed. Next we have two hardware interrupts, INT0 and INT1. These are called as hardware interrupts or like external interrupts only. Serial or like the timer is all internal. Hardware or external is like the control is given to the user, not the programmer. Don't worry about the programmer now. You have developed the model given to user. Now user can do some interact with the model, do some instruct the model to execute a particular piece of the code by using these buttons. By using these buttons, it is more related to the user. That is why they are called as external interrupts. Let us take one example. What is the example that we'll take? Like we'll try to yeah, this is my P3.2, P3.4. This is the easiest program that we have already written, but we are trying to use an interrupt and write this program. P3 point, some other thing you have to take. P1.3, P1. Right. Now, task is this. Whatever your program is doing, whenever I press this button, it should turn on the LED, this LED. If I press this button, it should turn on this LED. Whatever your program is doing, your program might be doing transfer. Guys, listen to this. Your program is to transfer 1000 bytes from internal memory to external memory. When it is doing that, if I press this button, LED 1 has to execute. If I press this button, LED 2 has to execute. It has to execute. It should not say like, I'll finish the 1000 bytes transfer and then like I will come and execute the LED program. Not accepted. Got my point? Please write a statement. Write a program. Write a program. Write a program. LED 1. LED 1 /2 whenever switch 0 or /1, switch 0/1, this is switch 0, this is 1, switch 0 or switch 1 is pressed, switch 0 and switch 1 is pressed. In spite of whatever the program that ALU is executing. What is the statement that we have written? Can any one of you repeat? Turn on LED 1 or 0, 1 immediately. You should use the word immediately there. Is it clear? Right? Done. So, what will be the program for this? It is very simple, right? We'll write one simple program. Hey, shit, we require this. To enable both the interrupts, what is that I need? I need this EX1 as 1 and EX0 as 1. The remaining as 0. That is, this has to be 1 anyway. 85, right? Right. What will be the program? Right. What is the location for this one? Interrupt 0, 003, right? ORZ 0003H. In 3H, what should I do? Okay. Set bit. Yeah, you can say, we have said turn on LED there. Turn on LED, right? You can say that we will write a CPL. Otherwise, if we do set bit, once we press it is on. Again, you have to reset a program, then do it again. So please mention complement there. Not set. Turn on alla, complement ಮಾಡಿ. CPL. What is the pin number? P1.3. RETI. ORZ 00 CPL P1.4 RETI. ಏನು ಅಷ್ಟೇ? Right. Next, what should I do? Main program ORZ. Say example 30H. What should I? T mod. What is T mod? IE register. Move IE, comma hash 85H. Why 85? We have got it from that thing. Then next, simply waste some time. That wasting time can be any program, as I mentioned. That's all. Is it clear? Right? Theoretically it works fine. Practically you should check. Why I am saying this? You have pressed the switch. Pressed the switch. How much time does it take to come from here, execute this and go back here? You are getting what I am saying? If in case it is, once you press a switch, it has to come to the this